Every moment of your life, invisible forces are shaping your reality. While we often take for granted the solidity of a table, the vibrant color of an apple, or the click of a smartphone button, beneath every one of these experiences lies a play of electromagnetic interactions. It's easy to imagine that our hand truly meets the surface of objects, that our fingertip presses directly against keys and screens. But the underlying truth is even more astonishing. You have never truly touched anything at all. Instead, the sensation of contact, the feeling of weight, the very structure of everyday matter, is all the consequence of electromagnetic repulsion, tiny forces at the atomic level that ensure the boundaries of objects and ourselves remain intact. Electromagnetism is one of four fundamental forces in nature, alongside gravity, the strong nuclear force, and the weak nuclear force. Of these, gravity may dominate our cosmic sense of scale, pulling planets and stars into majestic orbits, but at the level of atoms and molecules, the electromagnetic force utterly reigns. In fact, it is approximately 1 sextillion. That's a 1, followed by 36 zeros, stronger than gravity. Thanks to this immense strength, electromagnetic forces are what organize electrons into stable orbits around atomic nuclei, and what cause atoms to link, repel, and arrange themselves into the dazzling array of molecules and materials that make up our world. When we bring our hand toward a surface, what seems like physical connection is instead the effect of the outer regions of our atoms, namely their electrons, pushing against those of the surface. As two atoms approach, their electron clouds do not merge. Rather, they begin to repel each other in accordance with Coulomb's law. This law tells us the force between two charged particles depends on the size of their charges and drops off rapidly as their separation increases. With each nanometer closer, the pushback becomes exponentially greater, so strong that their nuclei never actually meet unless forced together with the power of a star's core, a process we know as fusion. We witness the wonders of electromagnetic forces in simple, tangible ways every day. Recall the playful magic of static electricity. Rub a balloon on your hair. And as electrons leap from your hair to the balloon, opposite charges build up. The resulting attraction makes your hair stand on end, dancing toward the balloon, each strand standing in silent tribute to the power of unseen forces. Or, run a comb through your hair and bring it close to a tiny stream of water. Watch as the water bends gracefully toward the comb, responding not to touch or wind, but to the electric field you've created. Even water, neutral to the eye, becomes polarized, its molecules aligning in response to the nearby charge. Beyond these visible marvels lie subtle effects like diamagnetism. Water, as unremarkable as it may seem, can actually be weakly repelled by a powerful magnet. In labs, researchers have even levitated small creatures, a frog, for instance, suspended in space by the collective diamagnetic response of its molecules to intense magnetic fields. Reality, it seems, is held together and shaped by influences we rarely perceive directly. Then there's light itself. Every beam and color that paints our world is an oscillation in the electromagnetic field. When photons, particles of light, meet with electrons in matter, they bounce, scatter, or are absorbed, all depending on the specific energies involved. The visual experience of color is nothing more than your brain interpreting the energy of different wavelengths, from deep red to vibrant violet. A green leaf appears as such because it reflects green photons, absorbing others. In this intricate dance, electromagnetic forces let you perceive form, color, and wonder. It's not just nature, either. Our technology thrives on these principles. Electric motors harness electromagnetic forces to spin, buzz, and whirl. Your phone is a triumph of electromagnetic engineering, from the magnets in speakers to the tiny electric fields that sense your presence. MRI machines peer inside the human body, aligning protons with powerful magnets, then reading the signals emitted as they return to their natural state. Every text, every voice call, every video stream is hurtling through space as electromagnetic waves, connecting minds across continents. Finally, for those who seek the deepest truths, Quantum electrodynamics, or QED, reveals the breathtaking elegance behind these interactions. Here, electromagnetic forces are described as exchanges of virtual photons, fleeting packets of energy that mediate every push, every pull, every flicker of light. Predictions from QED have been confirmed to mind-boggling precision, showing that the mathematics shaping your reality is astoundingly accurate. Next time you interact with the world, remember, every touch, every sight, every spark is the result of invisible forces working silently and beautifully at the smallest scales. Far from making life less miraculous, this understanding draws us even closer to the magic woven into the universe itself.